Hi everyone, it's Dr. Barden here. I'm coming at you from my office here just to talk a little bit about some just basic delay lines, the concept, how we utilize them in Max, the just general idea, all that kind of thing. I'll show you the three main objects that I mainly use for delays and just a few creative options. There's no real end to what you can do with them. You're essentially just taking a thing and making it happen a little bit later. So that's what we're going to focus on. So I've got a simple patch right here loaded up, ready to go. I'm going to show you the first most simple object, that being delay, which I'll also make a little bit bigger so that way we can actually see a bit of what's going on here on the screen. That should be plenty big. Oh, that's probably a little too big, actually. There, let's work with that. So the first one is just delay. You can call it Del, DEL for short, or if you want to spend the time to type out two more letters, it is just delay. I like to specify Del specifically because, as you might be able to see from the drop-down menu, there's another one that's delay tilde, which can get a little bit confusing. So just having some other way to differentiate these two is always a plus in my book. So del. If we make that right here, this object is specifically only for bangs. It will only delay a bang. It will not delay anything else. If you try to use anything else, you'll run into problems. As for how long it delays, that depends on what argument you give it. You can type it in after the name of the object, or you can send it as a message to this second inlet, and that is the delay time in milliseconds. So if I just wanted to arbitrarily say half a second, now anytime I send a bang into the inlet, half a second later, then it will output. So if I just click it now, you see there's a delay of half a second from when I first click it to when the second one lights up. Whereas normally it would look like this. Where it happens it's instantaneously. There is technically a small amount of delay, but I mean it's effectively instantaneous. And then because the bang is responding to an input rather than a click, the blink links are different. So I'm focusing on when the blink starts. So this is very handy for when you want to trigger something and have something down the line happens, like lighting a fuse. You've started the process, but stuff's going to happen later. Don't worry about it. So again, delay, that is only for delaying a bang by a certain amount of milliseconds. I'll pop open the help patch here just to make sure I'm not missing anything important. So let's see. Let's crank this one up to like 2.5, 3 seconds, because you can send it a stop message. I almost never have done that, so I'm curious if it will output it immediately or it'll just cancel it. So if I do it normally, wait about 2 seconds, then it bangs. But if I click and then before it would output, hit stop. Okay, so stop just cancels it. It's not going to output it immediately. So that's handy to know. You don't have to commit. You can send a stop message to your delay object in order to, stop it. And this is where you can set things up here if you work in the global transport, which I don't do very often, but it does have a lot of upsides for syncing things together. So if you're using Max a lot for live music that has beats and rhythms and a meter to it, you can set that global transport and then be like, hey, we're going to delay this by a whole note, a quarter note. all that kind of stuff, and keep all the delays in sync with the rhythm. So that's very handy. That's not something I do a lot with the music I personally create with Max and what I use Max for, but that's definitely a handy feature just to sync it up to, a BPM that everything is in line with. So delay is pretty simple. It delays a bang. That's about it. But what if you want to delay something other than a bang message? Well, there's two different objects for that we can use. I already mentioned one, delay tilde. Notice that it's not del tilde. It's the full word delay. There's no short version of this one. This one will function the exact same way, essentially. There's a few extra features just because it's working with signals, not bangs. But effectively, it's the amount of delay time. So we just have to specify. There's a little bit more information here. I'm going to open up that help patch just to indicate a few things. So with delay, we have to allocate the computer memory to essentially store that audio stream before we pass it along. So we're essentially, I'm just looking to see if I have something here. This will work. We are essentially taking a cup and filling it up with our audio stream, bit by bit. So I'm just going to be like, oh, hey, the stream's coming in. We're putting the stuff in. And then at some point, the audio we will say, okay, and now empty that out. And it'll empty out and go down the line. But we have to allocate that memory. And that's effectively the maximum amount of time that you can delay for. I think by default, it is in samples, which is, I mean, that's very specific and it's great for doing memory, but I don't really know anyone who thinks of audio in samples in most cases. But you just say how many samples you want to delay it for at maximum, so you can save that memory, and then you tell it what the initial delay time is. So if we hop over here, let's say I wanted to do something for 2 seconds and that my sample rate is, we can always look at our sample rate under audio status. Right now my sample rate is 44,100. So that's 44,100 samples per second. So if I wanted to delay it by 2 seconds, I would need 44,1 times 2, which would be 88,200. Be 2 seconds. And then the initial delay time, is that I think that's also in samples. Yeah, I think we're also in samples here. Just double checking. Never hurts to look. Yeah, and you can also use that global transport here as well. But delaying could be the number which specifies the number of samples or a note. Oh yeah, so number of samples. Just double checking there to make sure I don't give you wrong information. Number of samples. So let's say maximum delay of 2 seconds, and I want to start it off with a delay of half a second. Well, that would be half of 44.1. That'd be 22,500 is our initial. Making sure I didn't 50, not 500. Oh, it's like that looked weird. So that's our initial delay. And this will delay signals, like I said. So this is useful for if you play an audio file and you want to wait, delay, and have it go down the line. Where this can be a little problematic, like I mentioned, is these samples. So I'll mention a bonus object here, and that will be ms2samps right here. And that converts milliseconds to samples. So if we took this and if we just output, signal samples, I'm just double checking the double. Okay, but we could send this information to our object here. So delay time in samples, signal to be delayed. So if we were to connect this up, we should be able to then just easily say with a number box. Like if I want to set this to, 1 second, so 1,000 milliseconds, we should see the output be 44.1. Oh wait, I have to start audio processing because it's a signal output. Yep, 44.100 outputs right there. So we can use milliseconds to samples in order to, convert from milliseconds to samples. Because the signal rate is dealing with the samples, it's all signals there, but very handy for not having to do weird conversions and math on the fly. You can just say, hey, I want a delay of this amount, and it'll convert it all up for delay. So that's very, very handy. Let's just illustrate that real quickly. I'm going to hop over here and let's use, which one? Let's use Cherokee. That's one of my kind of go-tos that I like. Helps if I unlock the patch. And that's why I leave this windows open, because this window here, I don't click the don't show again because I do that all the time. Okay, Cherokee. Again, I've got this file just loaded up here. Let's just make a simple gain object and an easy DAC. So we can bloop. Control that, and we'll just, I'm pretty sure this is mono already, but we'll make sure by forcing it to be. So I'll start there, and we'll do a quick little test for the level, and you'll hear it as is. So actually, let's, can I just, no, it won't let me pull it out because it's connected to Chew. Okay, fine. I'll do it manually. My keyboard shortcuts don't always work for when I want them to work. But let's just do a test. You'll hear the file, and I'll also be able to see my levels in the meter to make sure that I'm not blowing out the video. So here's the core file. I'm just going to loop it while I just double check my fader level. So I'm just wanting to, we'll say about there, just a little under my voice in terms of talking. Yeah, well, we'll go just a little lower as well, because I'm sure that'll be annoying. I'm going to turn off the loop for there. So that's the sound file that we can work with. So if I go back here and we reconnect our audio up, there it is. So now there is a delay, and this will, I'll click it and it's going to wait 1 second before you see that audio come through. So if I hit play, it just, it delayed that signal by 1 second before it actually output it. So again, we're basically just storing it in a localized little buffer, and then at some point in the future saying, okay, now now we output the sound. So again, that's very handy for syncing things up, making sure that stuff is happening when you want it to happen. It's the foundation of feedback delay, which is another thing I'm going to mention in a little bit. So, let's just hop in there. I got distracted by an email notification popping up. Yay, work. But that's going to be the last thing I show, is just putting together some simple feedback delay. But before that, I want to show the third delaying object that I regularly use. This is the one I use the most, and that is called pipe. So this will delay anything except a signal. It can even delay a bang, but it's intended for numbers, lists, symbols, and anything pretty much else that can be delayed and isn't a signal. So if you hop that over, we just have to say, hey, what length do we want to delay this by? So maybe we'll go with the let's put it right in the middle at 750 milliseconds. So now, if I create a message box, hook that up like so, and send a let's do a slider. Why not? Connect the slider up. We'll see it as text, and then I'll show it visually with a slider as well. All right, actually, why not? Let's just put the slider here now. Line that up. So now we should see a 3/4 of a second delay from when I move the first slider to when the values pop up in the message box and the second slider moves. So if I start dragging, there's the delay. So again, it's delaying anything else. If I sent just a message here, or I guess it's technically be a list, but if I sent that in, it's going to be a half second delay from when I trigger it to when it pops up. Now this one's only going to show the first one there, but same kind of thing. I could do it. Unpack symbol. Just making sure I've got this. 2, 3, 4. I'm getting a little distracted. Yeah, hello, I like pie. So if I connect this up, hello. How are you today? So I'm picking up the 4-word simple sentence. Okay, for some reason, pipe isn't. Am I missing something here? Because it's only sending through the first message, but it should be able to do a list. Oh, we have to specify what some of this stuff is. So, okay, that's not the end of the world. I just don't normally delay lists. It's normally just individual messages. So, yay, surprise. And then some more advanced stuff here. So, trigger the delay within amount, stop the delay. Yeah, you can also stop it like before, but then flush is the command. That's what I was thinking of before, where if you stop the delay and output that current value, then it'll do it. So let's look at over here at the initialization. Can I make this taller? No, I can't. Okay. The number of arguments to the pipe object depends on the number of items in a list you wish to delay, but the final argument is always used to set the initial value for the delay time. If no argument is specified, it will be 0 milliseconds. So if we just go into our pipe and I just hop over here, these are 4 symbols, 1, 2, 3, 4. You should, when I click this now, see in the 3/4 seconds, should say, hi, how are you today? Really? Do I not say it's a symbol? They don't actually do it here. There are 2 arguments. Sets initial value to be stored in. Well, the pipe object. I'm reading all through the stuff here. I don't normally use lists, and now I'm on this whole little tangent that I wasn't planning on going. So I want to make sure that you can actually do the thing. Lists, send list. Take lists of up to 256 elements. Yeah, cool. So should I just say 0 point for all of these? I mean, they're not floats, but Maybe it's and Pac is just like pack, but I don't care about that. Okay. Now as a side note, Pac is almost strictly better than pack, but I'm not going to dive into that object right now. But I'm just double checking here. How are you today? Pack. Today you are how? How are you today? How are you today? Is it going to output them from independent things here? This is going to be the last one I check. How? This changes to R. Okay, yeah. So that was the last part I wanted to check. So if you send it a list, looks like it's going to output each element independently here. So I see that now in the help patch. So I'm sure people were just screaming at me as that was happening. But like I mentioned, I don't normally delay whole entire lists. Usually, I'm usually sending just individual messages and numbers here. That's the core takeaway is that Del does bangs. Pipe does just about everything else, numbers, etc. I'm going to tidy this up here. And then delay tilde does signals. So those are the important takeaways to have right there. So, and then also it's important to know that delay tilde, it helps if I unlock the patch, uses samples. You live up here. And the other two use milliseconds there. So I'm just going to specify that here in the sketch for that. So these are the main objects that you'll want to be using to delay anything. So this is the building block for all of our delay lines. So I'm going to scroll over a little bit here, and let's just build a simple delay line. So I'm going to make 1, 2, 3, 4. It's not going to be a very long one for the sake of the video, just to illustrate the concept. But let's arrange these up. So each bang represents, just a thing that's happening, and we're going to delay each one by, let's just say a half second each. Why not? So if we just do that, connect that in, connect that in, we've now created a series of delays. And if I trigger the first one, boom, 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 boo-doo-doo-doo-doo. Look, that's 120 BPM. But anyways, that's the basic delay line. So you could set it up like so, and it use that to trigger a lot of things, even just with a bang. So it's very handy. One thing I've done before is this. Get a keyboard slider. I forgot how zoomed in I was. MIDI to frequency. Cycle tilde. And basically use this to create some automatic playback. So if I wanted to create some stuff, hey, we'll just, instead of a bang, we're sending a message here. So actually it would be the same thing. So if I instead said message 60, message 58, message 60. I'm picking just real simple stuff. We'll do it like that. And then maybe we'll have a starting one of message. How about 62? We'll just do all whole steps. Connect that in. But then each of these can get connected into our K slider. This is when I would probably use a send to do that, but I'm going to just scooch these over here to hopefully make that just a little tidier. But a send would be a great way to just organize a lot of this. But I'm not going pretty much any more complex than this right now. But if we just connect all of these messages up, boom, boom, to that K slider, convert the MIDI note to sound, and then just copy and paste that over here so we can actually hear it and control the volume. That's about a third. So, all right. So if I lock this, set that to there. I forgot something still happening. I don't know what sound is coming through right now, but I'm going to trigger this. I'm going to pull that down because I don't know what sound is supposed to be outputting right now before I started playing, but you'll notice that when I trigger this first button, you'll see the played notes highlight right here. And I think if we even wanted to get a waveform, is this one right? Display start. Display. Now let's just do a you can see the sound happening here. That's going to always output stuff when I don't have an amplitude envelope. Yeah, that's there. Well, anyways, I'm getting sidetracked again. Here's the basic spectroscope. You can see it changing with each note. So like I said, that can be used to automate things, create melodies and whatnot, just to play automatically. So I made all of these to be 500. They don't have to be. Let's make this middle one 100 milliseconds and this last one 1500 milliseconds. Why not? I just arbitrarily pick stuff. You'll see the rhythm play here. So if I lock the patch. So it's more like boop-a-doo, doo-doo, boop-a-doo-doo, kind of a idea. We'll pretend I got those intervals right. But this is the core of the delay line, where a thing happens, it gets delayed, moves on, another delay happens, another. You're building this line, this series of delays where stuff happens. So with just a single input, you can trigger a lot of stuff. So this is very fun. Again, just to automate things. I'd have to go find it, but I remember doing a piece for a class I did a while back where it was all just MIDI delays, basically just like this, where I would specify, basically you hit one note, everything plays itself, which is fun. Okay, the last part I'm going to mention here is the idea of feedback delay. So let's make another cycle right there, and let's say boom. Actually, no. Let's use our audio file friend over here instead. Just so that'll be a little easier to tell what's going on than just a straight sine wave. So we'll take this as our sound source, and we're going to delay tilde, because it's a signal, that sound source by an amount. We haven't figured out that exact amount yet. And then I'll just copy these right here. So let's say that I always forget what they call them, but I was going to, like a dial. That's the one I wanted. Let's use this to control our delay time. So we just hit that up there. I'll double check in the parameters, number of steps, ranges. Let's just say up to 5 second maximum between delays. Let's make it a 1 second. So I got that this will output up to 1,000 for our delay. So what I'm getting at with the feedback delays, that if you're not familiar with it, is where you take that delayed signal and feed it back into the original delay. It's similar concept, different application to what we did over here, where you have a thing that gets delayed multiple times, being this initial bang being delayed several times. But instead of going through different delays, it's getting fed back into itself. So the same idea is that, feedback no one likes, but we're going to make it a little more intentional. If I was to play this right now, if I turn this to an amount, I should probably actually be able to see what that amount is. That would be nice. That much, why not? Then it's just going to be a normal delay. If I play it back. I mean, it's the same thing. It's about a half a second. Right there. So, oh, no. I always forget. This one is in samples. That's why I was like, that didn't look long enough to be 450 milliseconds. So now we have milliseconds, 2 samples. Stick you there. Now it should be about a half a second. Yeah. Anyways, I'm getting distracted by my meters and stuff. Something looks weird, but I'm not actually able to hear what's going on because it would feed back into my microphone. So I'll have to listen to this later and see if I just wasted my time. But with a feedback delay, if you were to take this output and plug it back into the input, that's what we're going to do. But you notice it didn't let me do it. Saying patch cord. Actually, no, that patch cord outlet out of. So you can't connect an output directly back into an input. I don't like that. Max is like, no, that's going to cause an infinite loop. That's bad. So what we can do is use our multiply tilde object and just stick it right there. And then we can go back into our delay. However, it's a bunch of issues just popped up of that, infinite recursion. That's again, it's just going to go over and over. It's not going to like itself. If we multiply by 0.5, what we can do is with this feedback delay is we can take this thing and it's going to feedback quieter each time. And then it will not be happy because Yeah, not going to be happy because of that initial delay. But the idea is that you make it quieter each time, and then that will make it less and less on each echo as we go. So the idea being it will echo through things, it'll repeat it, it'll delay it, it'll get quieter, and eventually it all zeroes out. That's great. If you kept it at the exact same level, everything would happen for forever. If you were to multiply it by something more than 1, it is going to infinitely just blow up and go just, it's going to get louder every time. It's going to continue forever. It's going to be a problem. So with any of your feedback delays like this, you're going to want to have that volume be less going back into the delay. But again, we'll fine tune this as we go. But general concepts here, I've gone through all of them. So if you have questions, concerns, always send me the email, stop by my office hours. The drill at this point, students. So we'll leave it off for there. I've got a separate video in Canvas that's talking about, that random sampler project. So if you effectively combine that with the delay things here, with delaying the signal and making it quieter each time, you can create everything on that project. So if you have any questions, let me know. I'm going to end it. Hello there, it's Dr. Barden. It was bugging me that some of that delay line was getting a lot of errors at the end of the last recording I did. So you're watching this just tacked on right at the end there. So what I've got on the screen right here, I'm purposely hiding a good chunk of it because this is my version of that max patch assignment, and I wanted to give away all of the answers for free there. But this is what I did for that echo option, and when it basically just kind of split the difference between the two. I split it up because I was tired of getting a bunch of errors. So again, a lot of patch cables here. I made this just kind of quick and dirty for the purpose of, hey, here's what it should do there. But the audio signal to be delayed comes in from other stuff over here, and then each of these delays I set up to be effectively the same. And I've got just one for each channel. So we'd go from 1 here, and you can control the delay time between each of them, but just go from 1, it delays it by an amount, gets half as loud, delays it, becomes 3/4 as loud as the last one, delays it again, becomes 85% as loud of the 75% of that. So the end result is it's about, the final echo is about maybe 30% of the original volume, nothing crazy. But then that all then goes back over to this other stuff where you can mix it in. But just that idea of, hey, we're going to delay stuff and make it quieter each time. That's how you get a very simple echo effect. It's something that can become even more effective, maybe with just a little bit of reverb on there. I'll let you play around with it. But this is, again, the very basic implementation of delay lines. I'm going to end this little snippet here, but if you have more questions, let me know. Stop by stop by my office hours, email, textbook, all that great stuff to help. For real now, I'll catch you later. Bye.